Hey guys, I'm going to run through a few problems here. I'm going to try to get it through as much as I can, as quickly as I can, but I also want to be thorough because there's a lot of thought that goes into these problems. So Andrew borrowed some money from his friend in order to help buy a new video game system. Andrew agreed to pay the friend back some amount every week until his loan was paid off. L is going to represent the amount that Andrew owes his friend after T weeks, meaning we don't know how many weeks. That variable L, the value of that, will change as time goes on because he's going to pay it back. They're going to have us write an equation that represents the amount that he owes and then talk about what the x-intercept is and what it means, how we interpret it. So here's the graph that goes along with this story. You can see certain highlighted ordered pairs, and I apologize if the numbers are too small for you to read. This is what I can do for the moment, since we've already read the problem. This right here is the ordered pair 2, 100. And remember, the variable that they're using here is T for time in weeks. So this is saying 2 weeks. And at 2 weeks, Andrew still owed $100. And again, as time goes on, like here, we know now that it's been 4 weeks since he got the loan. That's 4, and now it's $50. And so we can answer questions about this now that we've talked about 2 different spots, because he owed $100, and if we were talking about the change in the amount that he owed, it would have gone from 100 down to 50, which means he's changing his debt by 50, subtracting 50, right? But that didn't happen in just 1 week. It happened in 2 weeks. And so as I drew that little segment, I went from week number 2 to week number 4. That's 2 weeks. So if we prorate this or scale it downward to just 1 week, we interpret that as 25 every week. The other part of this is the we have slope. We just figured out the slope. That's what that is. The slope is negative 25 for every 1, which we would just write as negative 25. M. The y-intercept is also of importance because this had a debt of 150. And we would interpret that ordered pair this way. We would say that 0 weeks had passed. That's the point 0, 150. No time had passed, and he owes $150. Well, that's because he hasn't paid any of it back yet. That must mean that's how much he borrowed. No weeks had passed, therefore he hadn't paid his friend back at all. That must be the starting amount. That's your y-intercept. So your b value is 150. So the first part of this question is write the equation. One thing you have to be careful of is the variables that they give you. Normally, we write stuff as y equals mx plus b. But in this instance, they're telling us that my y-axis is basically described as the letter L, like it is here, equals m is still your slope. We're going to write that as negative 25. But it's not x, it's actually t, as you see here in the axis. And then the y-intercept is going to be the 150, so positive 150. Now, the next part of this is actually interpreting, again, what the x-intercept means. So we don't have to do work on this one to find the x-intercept. Normally, if we just had an equation, I would have to figure out how to find that value. But if I go to my graph, I look at the x-axis, even though it's labeled as t, this is still considered the x-axis for our understanding. So it's still considered an x-intercept right here. And that is the ordered pair 6, 0. And if we put it back into the terms that the problem was discussing, it says that there have been 6 weeks that have passed and $0 owed. So you would say the x-intercept is a 6. And when it asks about, what does that represent, you would say something, I don't know the choices are, I didn't save them on this problem, but after 6 weeks, the debt, the loan has been paid off. Okay? Bashir is a salesperson who sells computers at an electronics store. He makes a base pay amount each day and then is paid a commission as a percentage of the total dollar amount the company makes from his sales that day. So P is going to represent Bashir's total pay, and then X is going to represent the dollars worth of the computers. So there's 2 different types of problems that are along the same line. One of them is talking about how many computers they sell. The other one's talking then about a percentage of value that they would sell, and that's how they're paid. So these are 2 different types of commissions. One is you get a certain amount for every computer you sell. The other is you're getting a percentage of those computers' worth that you sold. So here's what we have. We have a graph. We can see that according to the graph, if Bashir sells $4,000 worth of computer equipment, then Bashir would make $140 on a day when that happened. If Bashir was able to sell $7,000 in computer equipment, then on that day he would make $200. So we know a couple things. As he sells more stuff, he gets more money. Let's talk about how that is changing. In other words, we're talking about our slope. At what rate is this increasing? Some students have been counting these blocks. You could go from here to here. Those were the 2 points that I pointed out. I don't need to. I'm just going to go from this point to this point because those are a lot closer. It means smaller numbers for us. But it's not a slope of 1. It's not up 1 over 1 in the sense that it used to be, because when I go up a block, I need to look at these numbers here. I went from the value of 140 to 160, even though I only went up 1 block. So what is the change in my Y value? Well, it went from 140 to 160. That's a change of 20. Then we talk about the change in the X value. Now, again, it's only 1 block's worth, but every block here is worth 1,000. So it's actually 20 compared to 1,000. So if Bashir sells $1,000 worth of equipment, he's going to get $20 added to his paycheck or his pay for that day. We can reduce this down. If we do 20 for 1,000, well, we can divide both of those by 10, and we'll get 2 for every 100. He gets $2 on every $100 that he sells, and that still simplifies down to just 1 for every 50. Okay? And 1 for every 50 could be written as a percent, this is a percent commission, so that makes sense. It goes back to kind of out of 100. But 2 out of 100 is a percentage called 2%, and you write that as 0.02. So either one of these is your slope. So we would write this out as his pay is equal to, he's either getting, $1 for every 50 that he makes in sales. The variable here is X for dollars, the dollar amount, and then his Y-intercept. Well, if Bashir goes to work and he doesn't sell anything, meaning he didn't sell $1,000 or $2,000 worth of stuff, he sold nothing. He still is going to earn $60, and that's the Y-intercept. And that's what's being said right here. The Y-intercept, what is it? It's 60. And if we look at our options, this time I did save those options. It looks like I moved them accidentally. The 60 Is he getting a 60%? Is he getting 60% of all of his sales? No, he's getting 2%. So 60 does not represent his percent commission. Does 60 mean that he sold 60 computers? No, we have no idea how many computers he sold. That's not even mentioned in here. Is 60 his total pay that he makes each day? That's kind of close, but when they say total pay, that means like he would always just be earning 60, nothing more than that. That would be his total. As you can see, his total changes. It's very different based on how much he sells. Is it the base pay that Bashir makes regardless of computer sales? Yes, that is what it is. It's the base pay, meaning he's not going to walk out of there. If he went to work, he's not going to walk out with less than $60. His base pay is going to take care of that. All right, let's look at another one. Sheen was given a gift card for a coffee shop. Each morning, Sheen uses the card to buy 1 cup of coffee. Let A represent the amount of money remaining on the card. So this is the amount. And then X is the cups of coffee, like number of cups of coffee. And so what happens is as the cups of coffee increases, as Sheen has bought 11 cups of coffee, the amount on the card is now $22.50. Sheen bought 14 total cups at this point, accumulative, not all at once. And now it's down to $15. And that makes sense. The amount on the gift card should be reducing as Sheen buys more coffee. The question we're trying to figure out here is determine how many cups of coffee. So we're trying to figure out some X value that Sheen had purchased so far when she had $37.50 remaining on the card. So the best way that I know to probably talk about this problem or figure this problem out without going super algebraic is to look at this table and just process it, figure out what does a cup of coffee cost, and then work your way backwards to the answer. So, for instance, I can see that when Sheen had purchased 11 cups of coffee, this was the remaining amount. Well, now Sheen has purchased how many more cups of coffee? Well, 3. That's 3 cups of coffee. And the amount here went from $22.50 down to $15. And so we want to talk about how much did that go down? That is $7.50. That means if we buy 3 cups of coffee, it is worth $7.50. Add it to the card if you're decreasing the amount of cups, and subtract it from the card if you're increasing the amount of cups by 3. So here's what I would do. I would say, okay, here's 14. This is $15 left. If we had only purchased 11, that would be $22.50. It's kind of like we're adding the $7.50 back on because we're working backwards on the number of cups that we're having. And the reason I'm going this way on my table is because I'm trying to get to this value of $37.50. So in my mind, I just need to keep adding $7.50 to this, which this would be $30. And I'm going to do it again. And I'll actually get $37.50 right then. And so this would have been, remember, we're going up by 3 cups every time. I guess up on the table, but down in value. That's now 8 cups is 30, had 30. And this would have been 5 cups. This also, again, a table. I'm just going to go quicker on this one because I've already probably said too much. Determine the percentage charge that Madison's phone loses each hour. So I've read these enough to know what we're talking about here. This is the battery and time. As time goes on, as we all know, if it's not plugged in, our battery is going down, right? And we are to understand something about linear relationships, which they do tell us here that this is linear. It's not true most of the time that our phone goes down by the same percentage every hour, but because this is a linear relationship, that is what's happening. So if I was at 67.5% on my battery, and now it's at 30% on my battery, then we have dropped 37.5% on the battery. But that didn't happen in 1 hour. It didn't happen in 2 hours. It happened in 5 hours. So if it was 37.5% and we're doing that over 5 hours, we go back to where we find our slope, right? You do 37.5 and you divide it by 5. It's the change in the y value divided by the change in the x value. So that one's a little trickier. 37.5 divided by 5 is 7.5, so negative 7.5. This is like the change every hour then. And that's what they're asking us to do. This, all they're basically saying is find the slope. And we did. It's negative 7.5% per hour. Next question. This is the third section of that assignment, and it comes more from just interpreting. You may, depending on the question, you might get luckier on some of these. Some of these are quicker and easier, like this first one. Others take a little more thought. So we have the weight in pounds of a newborn baby that is T months old after birth, and it can be modeled by this. Those that understand this equation already, I'm already very sympathetic for the mother that birthed this baby. The y-intercept of this, which it's laid out exactly like this, is 12. That's the y-intercept. What does it mean? My little joke may have given you a hint, but is it the number of pounds the baby gains per month? No, it is not. You should be able to answer that question because that is the slope. It's 1.25 pounds per month. Is it the number of pounds the baby gains per week? No, we could actually kind of figure that out by knowing what it does per month and then dividing that into a week. But this whole problem is not about weeks. Is it the weight of the baby at birth? Yes, it is. How do I know that? Because if we would say that the baby was T months old, when a baby's born, they're not any months old, so you would put that as 0. If the T is 0, then this value doesn't matter, and that's the weight of the baby when it's born. So that's what that's saying. That's the answer. Here it says the total weight gain of the baby. It's not that, right? It's this one. You select that one. You circle it better than I did, and you go on. Okay, so this one does take a little more calculation to answer. I have not calculated it yet, so I don't know the answer, but I'm aware of, the trouble that it presents. So Dylan is going to drive from his house to city A without stopping. That's important only for the sake of this continuing to be a line. An equation that determines Dylan's distance from city A, which is represented by the letter D here, at T hours after leaving his house. So T is the number of hours he's been driving on this trip. What is the x-intercept of the equation, and what is its interpretation in the context of the problem? So this problem is a little more difficult. Let's first talk about this equation, and then we'll talk about why it's a little more difficult. This equation, D equals 280 minus 35t, hopefully you're looking at it and you're already understanding why it's written this way or what those pieces mean. But you could write it like this, just so it matches this format. So we can already see then that my slope is the negative 35, and we can see that my y-intercept is 280. Now, one thing to remember about a y-intercept is that the x value, the input value, would be 0. And so this y-intercept of 280 could be written as an ordered pair, like this. And remember, this is t, the input, it's normally the x, right? This is t, saying 0 hours, and this is y, which is actually the distance. So it's saying 0 hours into the drive, and he's 280 miles away from his destination. That means that the y-intercept, 280, tells us how far his journey is that he's getting ready to make. The x-intercept, though, which is different than the y-intercept, the x-intercept would be represented by the situation when the y value is a 0. And that means there's some t value, and I don't know what it is yet, but if I figure out how long he's been driving and the distance from city A becomes 0, then I am basically saying if my distance is 0 miles away from a location, or 0 feet or whatever it may be, but if the distance is absolute 0, then I'm there. So we are going to just take this equation, I didn't mean to write it the way I did, so I'm just going to go ahead and erase the distance value, and I'm just going to change it to a 0. And that locks us in. We are trying to figure out what value of t would give me a distance of 0 here. And you can solve this very algebraically with our little procedures that we do. Or you can think about it, He's 280 miles away. He's going to cut into that distance 35 miles every hour. So how many times would this have to happen? How many hours would he have to do 35 miles to get to 280? You'll figure that out real shortly when you do this little couple steps. Now we're basically asking the question that I was just asking. How many times will 35 fit into 280? I think it's 8. T would be 8. So he is going to drive for 8 hours, and it's going to get the distance down to 0. So the x-intercept is 8. And the distance, so what does it represent? Does the 8 represent the distance from Dylan's house to city A? No, it doesn't. That value was 280 miles. Is it the average speed that Dylan travels in miles per hour? Remember, miles per hour, that's a rate. The average speed here is 35 miles per hour. Is it the total cost? We never even mentioned anything about cost. I don't know how much it cost him to drive this distance. I don't know the fuel prices, or for that matter, the fuel economy of his vehicle. Is 8 the number of gallons of gas used per hour of driving? No, once again, we never talked about gas at all. And then lastly, it's the only option left, but is 8 the total time of the trip in hours? And that makes total sense. It has to be. It's 8 hours. He drove 8 hours, and now he's there. Because how do I know he's there? Because the distance is 0. That's how you know you're there. All right, ciao.